Hello and welcome to my channel. So today let's look at today's daily challenge question. Leetcode 130 surrounded regions. Given m times n matrix board containing x and O, capture all regions that are four-directionally surrounded by x. A region is captured by flipping all O's into x's and in that surrounded region. So example is first example. This grid after the flip, only the middle tree O get converted to X. The O in the border will not be converted. So yeah, it's also like it's decided by four directions. So this O and this O is if you count the diagonal, it's connected, but they are not considered connected. So so for this example, uh, we can actually start from the border and find the O in the border. Then do BFS to find all the connected O, and fill and replace with a different value. Replace those cells, for example, with the F. The third step is third step is for the rest of O, you actually can replace those O's to X. And the last step is then you can replace F cells with F to O again. So that's finish the process. So yeah, let maybe give this example. We can yeah, given some example, we can actually show you how to do that. So like for example, there is O in the border, and there is O here, and also the O is connected to the, but it's only connected to one, this, and then this one maybe not connected. So or maybe we can give another O, and then and also there is O in the middle, like this O. So we can firstly we find all the O's in the queue, like in the border, and then we put them into the queue, and then we find then we start expanding. So we expand to, then we go to the four direction and expand to the O inside because it's two is connected. So during the process, we just change it to like F, and so this will be F and this will be F, and then we scan the border again, and then we change all the O which would not have to X. The last step is we scan the border again, and then we change those value back to O. So after this process, it will be the board we want. Okay, so let's start writing the code. So we can actually have the queue defined. So we can actually add all the coordinate of borders to the queue. Also, we want to define as usual for the grid, we want to define a direction vector. And also we want to get m and n as a global variable. Yeah, and now we can go scanning the border. So there are only 4 borders. Like we can firstly we scan the direction of a column. So if board or board n-1, this is one first column and the last column is O. Then we need to add them to the. Actually, we need to split this to 2. Yeah, and also similarly, we want to do the same for the road direction. So that is we can. Actually, we don't have to do this. I think we can do another. Is we can do the BFS. We can create another function called BFS. And because there is a disadvantage of doing this way is maybe 2 cells is connected on the border. So you actually add them both to the queue. So I think yeah, we can do the BFS so that it will. We just do the BFS in a separate function. Yeah, so here we just need to do BFS R0, like board. We don't add to the queue. Yeah, and um, it's actually here. It should be m minus 1. Yeah, and then in the board, also we want to define another function called maybe in area. This is checking if the coordinate is valid. Okay, so let's add this R and C to the and also we need to, as I mentioned, we need to change it to F. Then we can do the BFS to expand using a loop. So we do, yeah, and also we can now using the 4 direction. The array we define the director array, and then we get the next node, like the next cell coordinate for expansion. So then here, if this node is if it's not in area, then it's not a valid coordinate continue. If it is in area, then we can add to the queue. I think we also, if it's not if it's not a O, we actually also continue. So then it means it's a O, and then we can also change it to F, and then we add to the queue. So until this BFS is completed, we added the connected cells to the, and also we change it to F. So after this so the border has been checked, then we can do a loop and change all the O's to X. Yeah, actually, also we can do the same thing. The same like the logic we mentioned, that we want to change all the F to O. Yeah, and then after this is done, it should be done. So and the time complexity is time is O over n. N is the elements in the grid. Yeah, that's actually the time we generally get when doing the DFS. Also, the space maybe make the worst case is also O of n. So So it's the first example correct. The second example. Okay. Yeah. So this concludes today's session. So thank you for watching. See you next time.